So what we're gonna start doing in this video is putting together the fundamental pieces of axiomatic systems. Axioms are things that are essentially common sense, and axiomatic systems are ideas built off of common sense. So the purpose is to be able to explain to people who have no prior knowledge on the subject, but because they understand what we understand. They understand the notation, they understand the systematics of an axiomatic system. Then that is how people communicate scientifically. So we're going to introduce the one of the simplest concepts, and that is the division algorithm. D-I-V-I. Division algorithm. And the division algorithm is something you learned in like elementary school. It basically states that if you have some number b and you want to divide it by a, so say you have like 3, you want to divide it by 1, it gives you the same number. Okay, let's give it a more complicated. Say you have 9 and you want to divide by 3. So what you'll get is, let's say 10 divided by 3, because that's not a perfect integer. You get a quotient, which is the number to the left of the decimal, and you get a remainder. A remainder. Actually, I want to switch those colors. Quotient, remainder. Okay, now the division algorithm it says this in a style that is congruent to what we're doing here. Remember, the purpose of this class is to understand the system and learn how to write out ideas. So we're going to write it out like this. We're going to say let A and B, or we're going to let A be an integer. So A is an element of the set of integers, denoted like this, and B is a set of the natural numbers. Whoops, not equals, is an element of the set of natural numbers, denoted as so. And then we say there are, or there exists, and if we want to shorthand everything, then we write there exists is like a backwards E. It's not a 3, it looks like a backwards capital E. There exists unique integers Q and R. So there exists Q and R, which are elements of the integers. So that's how you say that. Such that, and we denote such that by, basically it's a backwards element sign. So usually you get a such that right next to an element of. So they always kind of seem like they're mirror imaging each other. So such that A equals B times Q, B times Q plus R. So for example, if we said that we want to divide 13 by 5, we write it like 13 divided by 5, we would get 2 with a remainder of 3. And that is all the division algorithm says. So let's try another one real quick. Whoops. Let me clear this, that. All right. 17 and 4. So we got 17 divided by 4. Well, what's that? 2, 4, 6, 8, 10, 12, 14, 16. Okay, so we know if we multiply 4 by 4, we get 16. So there's 4 4s under 17 with a remainder of 1. Oops, I wrote R. 1. Okay, so that's pretty basic stuff. Now, on to a slightly more involved theorem, and that is the fundamental theorem of arithmetic. I'm not going to draw that out. I'll just use my keyboard. Fundamental theorem of arithmetic. Arithmetic. Did I spell that right? Nope. I was educated in the South. Okay, so the fundamental theorem of arithmetic. What that says is... Actually, I think I'm just going to save it for the next video.